All right, there we go. Good morning if you are further away to the west in the States. Good afternoon if you are here in Europe or somewhere else in the world. A very warm welcome to this first of three webinars. My name is Jeroen Verberg and my co-host and partner and friend is Bill Bellows, Dr. Bill Bellows on the other side of the ocean. Welcome, Bill. On the 7th of May, we will launch quite a big event here in the Netherlands, in Dordrecht, in Hotel van der Valk, which we did a couple of times earlier. A big event in which you can experience how the ideal organization works, how you achieve operational excellence. An event where you can truly experience all the theory and what we learn as quality and operational managers, and you can experience it in the practical reality. And for that game, there are some management principles valid. The management principles that we teach in our courses and that we teach as consultants. And we thought, well, why not prior to that big event on the 7th of May, why not do a couple of webinars prior to that event? And that's where you're part of now. So this webinar is the first of three. And in these webinars, we will go through a couple of management principles that will be shared by Bill and myself for you to help understanding management principles, management rules. And today, the first one is the end of perfection. That's a topic that we love, the end of perfection. Everybody's always thinking in perfect tools, in perfect parts, in zero defects. Well, the world seems to be a little different than that, as we will show in this coming hour. So this will be the first webinar. You can make a note if you like. On the 20th of March, we will do the second webinar. And on the 2nd of April, we will do the third webinar. So today, the 20th of March and the 2nd of April. And if you like, and if you live in the Netherlands or in Poland or anywhere around, you can join us on the 7th of May on the big masterclass event in management. That is the introduction. Let's go to the content. Bill, if you like, you can take it away.
Great. All right, let me back. So anyway, thank you, Jeroen, and welcome everyone. Again, this is part one. The end of perfection, reflections on continuous improvement. And yeah, okay, so you can see on the right-hand side, you can see the bottle of water from a company in the States known as Arrowhead. And in their advertising campaign, they say, better has no finish line. A similar sentiment is revealed in the Olympic slogan, Citius, Altius, Fortius. And it's not often I get to say that during an Olympic season. And yet many organizations today maintain a steadfast commitment to eliminate variation and non-value-added activities, all the while in pursuit of a quality goal of zero defects, a productivity goal of zero waste, which are seen together as the attainment of perfection. Yet, might it be possible that finish lines, such as the achievement of these goals, stem from how we, within our organizations, think about our efforts as separate, as opposed to connected, and not how they connect to one another. And what I've learned from Dr. Deming is to perceive improvement as continuous requires thinking past what I would say is an illusion that these tasks, parts, and actions and efforts are separate. They aren't separate. They're really connected. Leaders think beyond such barriers by perceiving them as mental, and we're just conditioned to think about these things as separate. Okay. So I've divided this session into these parts, an intro, concepts, going back to what Jeroen mentioned, some key management principles, in search of excellence, and then what I refer to as the four suppliers exercise, which will involve the use of Mentimeter to have each of you be able to weigh in and make a decision. So Jeroen, everyone has that link, right?
I will share it in a second. Yeah, when we go to the Mentimeter, I will share it. Yes.
Okay, fantastic. And then some closing thoughts. So the intro. So influencers, we didn't use that term in the day, but in 1987, I met Junichi Taguchi and spent a great deal of time with him. He was born in 1924, passed away in 2012. And his work became noticed in the States and probably even in Europe in the early 80s, 83, 84 timeframe. So we're going to look at his concept of quality loss. In the center of 1990, I met Dr. Deming for the first time and met him a few years later. In fact, he was very well known around the world for offering a 4-day seminar. And I happened to be fortunate to attend his very, very last seminar. He died 10 days afterwards. In fact, the seminar was here in Los Angeles, not far from the Hollywood Bowl. So we're going to look at his ideas this morning as well. And then on the right-hand side, Russell Lakoff, who I met in 2003 and spent a great deal of time with. And we're going to look at the influence of his thinking as it combines with Deming's thinking and Taguchi's thinking. Okay. So in Dr. Deming's seminars, in fact, his very last one, he used this quote. He used to say, "Are you in favor of improvement of quality?" And then he would mutter, we could have a national survey, yes or no. And he'd say, everyone says yes. And then he'd go on to say, and everyone's got the answer. And most of the answers were the use of technologies, which if he was alive today, the answers would include artificial intelligence, the Internet of Things, all in the category of tools and techniques. A cell phone is a tool. Technique is how to use it. But what's missing in organizations is not the use of tools, which I'm not against, but the strategy and the concept by which we use these things. And that's what I want to give some insights today. What is quality? Well, the classic definition of quality, one I see practiced every day in my consulting and my university courses, the traditional definition of quality, alive and well everywhere with rare exception, goes back to Philip Crosby, and his quality is defined as conformance to requirements, not as goodness, not as elegance. Zero defects, another way of saying do it right the first time. The performance standard must be zero defects. And what we're going to look at is, if we achieve zero defects, if we're striving for zero defects, and achieve that, has the improvement of quality ended? And from what I see, when I read, looking at Six Sigma quality, zero defect management, operational excellence, they're striving for zero defects. They're treating zero defects as the end of quality improvement. And that's unfortunate because it denies improvement. And so this is an article I use in my university courses and consulting just to remind people that striving for zero defects and all of the thinking around why we need zero defects is alive and well. I worked in aerospace pretty much my entire career. 7 years in Connecticut, where I was a heat transfer engineer in a jet engine business, and then here in Los Angeles for 26 years for Rocketdyne, the company that made the booster engines for the Apollo program. Pretty much up until Elon Musk started sending astronauts into space, every human launched into space was powered by engines made by Rocketdyne. So I was there for 26 years. The big product at the time was the Space Shuttle main engine. Part of the time I was there, we were owned by Boeing. Boeing's advanced quality system, which is considered the aerospace standard, strives for zero defects. So that thinking is alive and well. But Dr. Deming had a different definition of quality. Dr. Deming's definition, and this comes from his book, The New Economics, came out in 1993. He says, a product or service possesses quality if it helps somebody and enjoys a good and sustainable market. So my interpretation, my explanation of Deming's definition of quality is it's not judged by me when I deliver to any of you. It's judged by you. So this is if this is a high quality lecture, I'm not the judge, you are the judge. And as opposed to what Phil Crosby is coming from, is that when it leaves my hands that it has met requirements, then I'm the judge that it's good. What Deming's talking about is quality in the sense of how does it serve the system, not looking at my part in isolation. We're going to look at that. So in the mid-'80s, actually the early '80s, when Dr. Deming was becoming popular in his first book, Out of the Crisis, he included 14 points for management. When I left Rocketdyne, I worked for Dr. Deming's nonprofit, started just before he died, known as the W. Edwards Deming Institute. The website is Deming with one M, Deming.org. I was there for better part of 3 years. And our website at the time on the 14 points was one of the most frequently visited websites. Okay. And not to go through all of them in detail, but the fifth one, improve constantly forever the system of production and service. And again, I ask, how can you improve constantly forever once you've achieved zero defects? Are we done? Are we done? And then, right, eliminate slogans, exhortations, and targets. Put everyone in the company to work. Okay. Concepts. Perfection, dictionary definition of perfection is having all the required or desirable elements, qualities, or characteristics as good as it is possible to be. All right. That's pretty encompassing. But to me, it's also a finish line. Absolute, complete, absolute, not relative, right? Continual improvement is about things being relative. It's going from good to better, to better, to better, and better, and better, and better. Absolute is done. Make something completely free from faults and defects. And what I've seen in my consulting career and in my time in aerospace, in fact, I spent the last 4 years consulting for another aerospace company, Blue Origin, Jeff Bezos' space company. Okay, so I'm quite current in terms of how focusing on perfection, focusing on zero defects is the standard, unfortunately. Here's a billboard for Arrowhead Water. Better has no finish line. That's where Dr. Deming was coming from. Better has no finish line. Better is our nature, is what we were born to be, so refreshed with the water sourced only from carefully selected 100% mountain springs. one of the first times I visited Disneyland, which is about an hour south of us, saw this sign in the lobby of a hotel on the property. It says, Disneyland will never be completed. It'll continue to grow as long as there's imagination left in the world. I think striving for zero defects, to me, is an everyday example of a lack of imagination. Thinking we're done. Donella Meadows, in her book, Systems Thinking, talks about synergy. She says, you think because you understand one, you must understand two, because one and one makes two, but you have to also understand and. And so when you look at things in isolation, you have zero synergy. 1 + 1 is 2, which is, again, an explanation I would use to students is 1 + 1 is 2 is that two people working separately can accomplish the work of two people. So if they're digging a trench and it's got, it's 20 feet long and they start at opposite ends, they're working separately. That's zero synergy situation. 1 + 1 is 2. If they're to work against each other, to interfere with each other, then you get negative synergy. 1 + 1 is less than 2. And what Dr. Deming's 14 points are about is trying to make 1 + 1 greater than 2. But if you lack an understanding of what he's talking about, you'll end up with less than 2, striving for 2. Positive synergy is when those two people digging the trench, instead of working separately, start at the same end. And it could be that one uses an axe to soften the soil. The other then uses the shovel to shovel the softened soil. And there's a good possibility that in that situation, working together, they can accomplish more than two people working separately. Well, what I'm going to be sharing with you is if you look at quality from a positive synergy perspective, then you go way beyond what today's system is. Today's system of looking at the quality of parts in isolation is a zero synergy look at quality. What Deming's talking about is a positive view of quality, a synergistic view. Okay, and I'll give you some sense. All right, in search of excellence. And this is inspiration from Ford. Comes from reading a book entitled Prophets in the Dark. The senior author, David Kearns, was at the time, or I think he had just retired, he was the, at the time he had retired, he was the CEO of Xerox, the reproductive photocopying company. And in the book, he says in the late 60s, Frank Pitt, an assembly plant manager for an American automobile company, which turns out to be Ford, instructed his team to purchase competitors' cars. His plan was to have the final assembly team disassemble these cars and learn firsthand how they assembled. Well, what he found is that the competitors' cars assembled just like at the Ford plant. And just like means when they put the mating parts together, mallets were used to bang together the mating parts. And every once in a while, two parts of a Ford automobile at their Pip's assembly plant, now and then two parts would go together without a mallet, which the Ford plant called snap fit. Most of the time, mallets were used to bang things together. Now and then they were snap fit. And he somehow had the insight to buy competitors' cars, and lo and behold, they assembled with mallets just like theirs, because they all came from the same model of looking at parts in isolation. So he continued to do this over the years. Then they bought the product of a brand new competitor. As usual, took it apart, put it together, and they reported back to Pip that it was 100% snap fit. They'd never seen anything like it. He did not believe the results. He had them take it apart again, They assembled it a second time, never used a mallet. He was so astounded by the results that he had senior executives from Ford Corporate come see this. The team came out, met with the assembly team, heard all the details, and the senior-most Ford executive said the following: the customer will never notice the difference. Pip was so frustrated with that answer that shortly thereafter he quit, went to work for Xerox, and brought what he had learned to Xerox. Okay. If two connecting parts were assembled without the use of a hammer, they were known as snap fit. In Pip's experience, snap fit was rare. To his amazement, one competitor's car was discovered to be 100% snap fit, for which the GM replied, the customer will never notice a difference. Slowly but surely, customers have noticed the assembly and performance results that Pip's team found in 1969 when they first examined a Toyota pickup truck. And so I use this example within Rocketdyne and provided them an explanation of how to achieve snap fit, which we put into practice repeatedly, and the details of which we'll look at in the second and the third seminars. But tonight I want to give you a sense of what a dramatic difference that is, and how the thinking that Toyota used is the thinking we use at home. Because at home, we don't look at things in isolation. At home, we're responsible for all the parts of whatever we're making. So at home, we naturally look at what we're building, whatever that project is. It could be planning a wedding or planning a vacation. We don't look at the parts of a vacation as separate. We understand how they fit together. And so the good news is we have a great understanding of how to do snap fit at home. What's missing is we don't understand how to do snap fit at work, because work is a different system. Because work's about parts. Some insights as to how natural this is. Call it the paradigms of variation, selecting fruit. And so a question I've been asking people for 25 years, actually a little bit more than that, is if you were to go into a supermarket and I told you that all the fruits and vegetables in the supermarket were not bruised or otherwise physically damaged, would you expect to see people sorting through the fruit? And the answers are split. Yes, I would just go up and pick up an apple. In fact, probably most often people said, no, I won't sort through. I'll just go up, grab an apple, grab an orange. And then maybe 1/3 of the time somebody says, no, I sort through the apples. And I said, why do you sort through them? Because they're different. They're not the same shape. They're not the same ripeness. If they're dealing with oranges, they're not the same, juiciness. Had a guy in class once who said, no, I don't sort through the oranges. I buy them by the bag. I said, well, do you sort between bags? He said, nope, with his arms crossed. He said, I don't sort. I said, okay. I said, I noticed on your left hand a wedding ring. He said, yes. I said, did you sort before you gave it to her? He said, yes. And so sorting is what happens when we see things that appear to be the same, yet notice differences. We do that all the time, whether it's buying fruit, picking a parking spot which is closer to the door, because we say parking spots are not the same, they're different. Well, in the world of interchangeable parts, the thinking we use at work is apples are apples, doctors are doctors, oranges are oranges, go get me 5. So at work, we have this model in our head that the organization uses that says, don't sort. They meet the requirements of being an apple. They meet the requirements of being a doctor. Just go get 3 of them. Dr. Deming and Russ Akoff met because they met for the first time in the early 50s. They got together in 1992 for 3-4 hours, and that got condensed down to a 30-minute video that Deming Library has, and it's called Volume 21 of roughly 32 or so volumes. You can find pieces of this on YouTube if you just search for Deming Library Volume 21. So that's Russ Akoff on the left, Dr. Deming on the right. And in this conversation, Russ, who taught at the University of Pennsylvania for most of his career, Russ says the following. He says, the characteristic way of management we have taught in the Western world is to take a complex system, divide it into parts, and then I added elements, tasks, etc. And then back to Russ, and then try to manage each part as well as possible. And if that's done, what? And so this is a question I ask, in seminars that I do. And I ask people, how would you complete this sentence? Right? And then they come back, and roughly 75% of the time they will say something along the lines of the system will behave well. I said, well, that's what Russ said. But then Russ said, and that's absolutely false. And so on the one hand, the majority of people think it will behave well, not absolutely false. But if you ask people, what would you do instead? They really don't know because we're so used to managing the parts as well as possible. And so what I'm trying to do in today's session and then build upon the next two sessions is show you how this is not what we do at home. At home, we look at things as part of a system, and that makes all the difference. Russ goes on to say, a system is never the sum of its parts. If it was the sum, it would be zero synergy. Sum is addition. 1 + 1 = 2. Russ says, no, it's the product of the interactions of the parts. The art of managing interactions is very different than the management of actions, and history requires this transition for effective management. So to look at each part and say it's good, to complete each part to be good without looking at the other parts is to manage actions. So if you can complete any activity and not talk with anyone else in the organization about how they're working on their piece, if you can separately meet the requirements, that's managing actions. Managing interactions is that I cannot complete my task without knowing how you're completing your task. That's what we do at home, because at home we're managing both. And then we go to work and break it into parts. Everybody's got their own striving for zero defects mindset. That's not what we do at home. So another question, and these questions are part of the one-day program on May 7th as well. And there, and so what I was seeing at work is people just striving for zero defects, striving, if only, if only, if only. So then I started asking them, well, what would happen within your organization if at the beginning of operations tomorrow, all processes produce zero defects and remain this way forever? What if? Right, which goes back to this. And if you look at this article, a $2 part can bring a $40,000 piece of machinery to a grinding halt. Well, if you achieve zero defect, you don't have that problem anymore. So what I started doing with coworkers at Rocketdyne was say, what if we achieve this goal you're striving for? What would change? What changes would you begin to imagine to occur hour by hour, day by day, year by year, as more and more people became aware that zero defects has been achieved? How would that change? And one of the first times I did this was a quality engineer. And he says, Bill, my job would go away. And a few minutes later, he said, there'd be no need for the quality organization. Well, striving for zero defects, we're going to look at, is not all that it's cracked up to be. Not all that it's cracked up to be. Yet, that's what organizations try to do.
Every day.
Right. Now we're going to get into the we call it next part, the four suppliers exercise.
Yes, that's interesting.
All right, so, and this would be an audience participation activity. And in part one, there's 3 parts of this supplier exercise. And in each part, I want you to pretend you're the senior buyer in the purchasing department of a design and assembly company assigned with the task of selecting a supplier of short metal tubes that are used in one of our products. In a highly idealized and simplified situation, imagine you've received the following decision feedback from the 4 candidate suppliers and your company's design team. Imagine all 4 suppliers, 1, 2, 3, 4, offer the same purchase price for the tubes. Again, amazing but valid. Okay. All 4 suppliers offer the same delivery schedule of the quantity of needed tubes, also amazing, also valid. And if that's not enough, all 4 suppliers guarantee, and you have no reason to doubt it, that the tubes they deliver will be defect-free on the outer diameter of the tubes, which is the only quality characteristic you need to consider in order to achieve zero defects. Even more amazing, also valid. Okay. So given this scenario, which supplier would you choose for the procurement? As a 5th option, your decision can also be that it doesn't matter. So one of the options is I'll take any of them because you don't think there's a difference. Okay.
Yes, and now we're going to switch, Bill. So if you can stop sharing.
Okay.
And this is very experimental. Then in the chat you'll find a link to Mentimeter. And I'm going to share Mentimeter. If you have some time to click on the link and find the Mentimeter profile, and I will share it on the screen as well. You can also, you should be able to see on the right side a beautiful, intelligent man giving training during the master class in 2025, but as well you'll see the code there, and you can answer the questions if you like. So there we go. Give it some time, give it some thoughts. And we are on the move from 10 to, we're 15 participants. And see who is the supplier that's going to be chosen. I had a music planned for this exercise. I forgot that. I will do that in the next round.
You can sing, Jeroen.
I can sing. Well, let's not do that. That's not a good idea.
I just wanted to comment. If you don't sing, that's fine.
That's not a good idea. Is everybody able to enter it? 17. I still people coming in. All right. Well, there's your result, Bill.
As I expected, any of them is the most popular answer.
I will stop sharing and you can take over again.
Okay, great. Okay, great.
Keep your Mentimeter on. We come back to that 2 more times.
Okay. Yeah, and so part two, yeah, some additional information. All four suppliers provide histograms, which I'll show you on the next page, of the tube outer diameter results, process results, which are guaranteed from their respective control charts, say quality tool, to remain in control, meaning that the guaranteed process stability, all the more amazing, all the more invalid. Thereby, there'll be no changes to the average, no changes to the amount of variation, its location and shape. And in addition, the tubes are used in assembly operations as procured without modification. Your job is to select the supplier. We don't modify them. They go to assembly and they're used immediately. So what if, and also number 5, so this is in addition to 1 at the same price, 2 the same schedule, 3 0 defects guaranteed. I'm going to show you the distributions and also point out that there's a minimum requirement, otherwise known as the lower spec or the lower specification limit, and a maximum value, otherwise known as the upper spec or the USL, for the outer diameter. And these were selected in cooperation with the design team in partnership with production teams at all 4 suppliers. Okay. So what if these are the 4 distributions of the outer diameter on a range from the minimum value to the high value? And so again, your options are 1, 2, 3, 4, or any. So using the next part of the Mentimeter, let us know how you would make the decision given this additional information.
Yes. Do you still have access to the Mentimeter? We can share it again.
Should I unshare now?
Can you, yes, can you...
Yeah, I just want to give people long enough to be able to get a sense of what their choice
it is an intelligent population that we have online, Bill.
All right, stop sharing.
There we go. So we go to part 2 now. This is the second one. Which of the deviations, which of the Gauss curves would you select?
Please see the Gauss curves one more time.
Do you want to see the Gauss curve? Then we go back again. I will stop sharing. Bill, can you share again? Take your time. We'll wait for a little longer then.
Yes, thank you.
We have number 1, 2, 3, and 4, or any, and these are in the Mentimeter as well. 1, 2, 3, and 4. You need a moment of thought, Ben. That's all good.
Yep.
Yeah? Can you stop sharing, Bill? Then we can see the results.
All right.
This goes pretty smooth, smoother than I thought. There you are. Number 3 is the highest, any of them, and so on. Not everybody yet filled in, I see. Maybe you can help them out a little bit, Bill.
Oh, what's that?
Maybe you can help them a little bit. That's cheating.
So go back to back to the slides. Okay.
Yeah. So number 3 is the most popular, and then any of them.
Allow multiple presentations. Allow. Okay.
Yep. So the number 3 was most popular, the green one, and any of them.
As part 2.
Yep, that's part 2.
These are results from a university course. And what I found in offering option 2, since 1995, the fourth supplier, supplier four, was the dominant choice. In fact, typically 75 to 80% of the audience would select four, no matter where I was. In 1 week, I was at a Philips light bulb factory in Glasgow, Scotland, and exactly 3/4 selected four. And the rest selected three, and the rest were ones who were attending for the second time, so they had some insights. And then a week later, I was presenting it to the at a Boeing fighter plane factory, and exactly 75% selected four. So it's not uncommon that four is the dominant answer. In this case, that's not the case.
Exactly.
But it could be that a few of you have seen this before. Just like at the Philips light bulb factory, the ones who selected three were going through the course the second time. In fact, once I was in a Boeing seminar, doing a seminar within Boeing, and instead of having them individually use Mentimeter, I just said, okay, let's go around the room. First person, what did you put? Four. Next person, four. Next person, four. Next person, four. And the very last person, after 20 of them, said three. So again, four is the predominant answer in an audience where people have not been exposed to this before. Okay. Now part three. Part three. What if, in addition to everything else we have shared, you know, the min and the max, okay, that all stays the same. But what if, in addition, there's an ideal value associated in cooperation with the design team in partnership with the production team? What if I now tell you, go back to the distributions, what if I now tell you there's an ideal value, and that dotted red line in the center is the ideal value? So given that there's a preferred value, go back to the Mentimeter for part three, and let's see if that changes your answer.
Again, there is an answer possible 1, 2, 3, and 4, and any. So it's
Yes.
the same options. The same options. Have a little bit longer look at this graph before we take it away.
Yep. So the only difference is
There's an
you're
ideal
now
value.
told an ideal value, which the team says is preferred.
All right, there we go. Bill, can you stop sharing?
Okay.
And we go to the next slide, number 3. Which supplier would you select with the additional information? To make it also practical, this topic, we're talking about parts matching together. I'm sure you recognize in your organization that departments should work together. And the reflective question for your own organization would be if organizations are indeed working together. And working together doesn't mean having a meeting for solving problems and creating long action lists. Working together means understanding the customer's ideal value and working together on that matter. So maybe you can think of some meetings in your own organization where this topic is indeed on the agenda, or is it another type of meeting that you're used to? All right, where are we? Number 3. All right, let's stop sharing, and Bill, you can take it over again.
Okay, great. Yeah, so here we found, and it's not uncommon, that as soon as I call out 3 as ideal, that will change people's answers from 4 to 3. However, what I found with people that are brand new to these ideas, calling out preferred does not change the answer. In fact, going back to 1995 when I started this exercise, I always told them the preferred value. So from the very beginning, when I called out the preferred value, it was ignored and supplier 4 was selected. And it was years later, I said, well, what would happen if I didn't call out the preferred value? Same answer. Same answer. It's as if preferred has no meaning, which to me infers that we're so focused on meeting requirements that going beyond that was saying, we want you to meet requirements and here's preferred value. Well, preferred value is ignored. What we go back to is, have we met requirements? And so even when it's called out, it's ignored. In fact, at Rocketdyne, when we first demonstrated that snap fit comes from an ideal value thought process, but it's not just I meet my ideal value. Jeroen, you would also have to be focusing on your ideal value simultaneously. And that's where the teamwork comes in. Because if I focus on the ideal for mine, but you don't, then you don't get snap fit.
Oh, but I got a completely different KPI, Bill. I have a different KPI than you have. So,
Yep. Yep. So if you focus on meeting the requirements if you strive for the minimum hole size, or actually for the outer diameter, you would most likely be focusing on the maximum outer diameter. If we talk to the people that make the holes that the tubes go in, they would be made to the minimum size. And neither one of them is looking at how well they fit together. Yet at home, when I own both, I'm making sure that the hole and the outer diameter are aligned. And that's how we got snap fit at Rocketdyne again and again and again. Because at home, we understand this blue curve. We may not have seen the blue curve. The blue curve comes from Dr. Taguchi's work in the 1950s in Japan. And his proposal is, instead of viewing quality in terms of if it's within spec, good, out of spec on one side, scrap, out of spec on one side, rework, what Taguchi has in mind is the role of the target value. When you're cutting that piece of wood at home in the garage to be this long, you're doing so because if that piece of wood is a little bit longer, it might be more challenging for you to put that piece of wood into the thing you're building. And if it's too short, you likewise have to compensate. And so what the blue curve is demonstrating is the amount of extra effort required by the people that use this because you're not on the ideal value. So the proposal is, at home, intuitively, we don't see the blue curve. The blue curve is not in our head, but we're acting as if we understand that it matters, which is why at home, when we cut the piece of wood, we don't draw two lines and say cut anywhere in between. We draw one line and aim for the line. Had a machinist at work years ago in a seminar, and I said, so why at home do you aim for the one line and then at work anything in between? He says, Bill, that's easy. At home I cut wood, at work I cut metal. I said, but who designs it at home? He said, well, that would be me. Who bought the wood at home? Well, that would be me. Who puts these parts together at home? That would be me. I said, who designs it at work? Somebody else. Who does final assembly? Somebody else. I said, do you think that might have something to do with the difference between the striving for the one line and striving for anywhere in between? And so the strategy was to show people at all different levels of the organization that if we cut the piece of wood at home, why do we do that at home? Because at home, we own integration. And so we achieve snap fit again and again and again at Rocketdyne, which not only improved how things came together, we also demonstrated that it dramatically improved the performance of the rocket engine by paying attention to how things came together. And to me, that explains why Toyota is as good as they are. Now, the question becomes, how steep is that blue curve? If you're off target, does it go up a lot? Does it go up a little bit? Does it go up maybe not at all? And these curves you may recognize as parabolas, which Dr. Taguchi shows, and we'll look at it in a future session. It is a parabola as a first order approximation, and it comes from calculus that we would think of loss continuously increasing from an ideal value. And what this curve demonstrates is, in a Deming organization, when you have an understanding of the shape of the curve, that guides you as to where to locate the variation and how much you need. So if that curve is very flat, then it's another way of saying it doesn't really matter where you are. If the curve is very steep, then it tells you that's a place where we got to put some effort and continuously improve based on the shape of the curve. Now, continual improvement is not forever. So on the one hand, we wouldn't necessarily stop at 0 defects. On the other hand, we're not going to strive to make the curve as narrow as possible. What we're going to do in a Deming organization is compare the cost of being at the minimum on the curve with the savings by being on the minimum. So we would gladly, in a Deming organization, spend $1,000 to adjust the processes to be on target if it saves us more than $1,000. But we're not going to just go off and reduce it because. So there has to be a balancing act. So the proposal is that this is not improvement thinking, this is investment thinking. So we're going to spend time to manipulate the distributions, but that time must be paid for with downstream savings. And we're going to look at those equations in the future sessions.
Bill, we are at 55 minutes. You had a couple of more slides. We had a Q&A moment if people want to ask questions.
Yep.
Please.
From Dr. Deming, a better description of the world is the Taguchi loss function, in which there is a minimum loss at nominal and ever increasing value as we depart from that. Closing thoughts.
Mm-hmm.
Improvement can be greatly advanced by acknowledging self-imposed restrictions on our thinking, specifically thinking in terms of good parts on budget tasks, rather than in terms of the interactions between the parts and the elements, not these efforts taken separately. Going back to what you said earlier, Jeroen, call it teamwork in the end of 0 defects, 0 waste, and perfection as finish lines. And then next time, March 20th, we're going to look at learning to discern quantity and quality that takes critical thinking. And there, while counting the number of employees to the number of products shipped is quantity-based, the differences between the entities that are being counted, right, is quality-based. So we have 15 tubes, but how the tubes are used is quality-based. For an aircraft manufacturer, if the parts of an airplane remained in boxes and were never assembled, then the variation in the parts, as in the variation in the employees, would be hard to discern. Variation appears in how well the parts are eventually integrated into the system and how the system performs day after day. All right, so that's a preview of what we'll do next time.
Oh, wonderful. Thank you very much, Bill. Thank you. Thank you for your contribution. Before people leave, and we go to the Q&A if you like, remember then the 20th of March, the next session, if you like to join with your colleagues, partners, whatever. If you think this is useful for other people in your organization, please feel free to join the next time on the 20th of March. Now we're going to go to the Q&A if you like. Are there any burning questions? If English is an issue, I can translate for you. Are there any questions regarding this management principle that will be explored further on the 7th of May? Anything they want to share an experience regarding this topic? Do you recognize this in your own organization, that workers are working hard, striving, doing their best, but it's pretty hard to work together, because for that you need time together. You need to work in teams. You need meetings where you do analysis and measurements. And a lot of organizations, the complete focus is on meeting the planning, and there is almost no time to sit together and do these kind of investigations. It's at least our experience as consultant. Any burning questions?
I have a question.
Yes, please. Go ahead.
Listening to your end conclusion, I was wondering, this all sounds very feasible, but we're living in a digitalized world where people are not together, right? We're all working from home, etc., etc.
Yes.
How does that challenge come into the equation?
Good question. Thank you. Brilliant, Willem. Yes. You want to go on that, Bill, or shall I take it?
I'm not sure I understood the question.
The question is that nowadays people are working from home. They are separate from each other instead of physically in a room with the parts, with the machines, on the shop floor. Well, at least operators in a factory normally go to work, but quite a lot of other managers, engineers, lawyers, advisors, quality managers are working separately from each other. We're trying to connect it in a digital way. How is the challenge on that? It is definitely a challenge. I agree with that, Will.
Well, I'd say that. Great question. What I've seen in organizations, non-Deming companies, is they move people to be physically closer together, but they're still mentally separated. Right? So the issue is that, so in a non-Deming company, I meet requirements, well, and then I give them to you. I'm sitting next to you. I give it to you. You bang it together. Do I feel any sense of causality to your banging it? No, because my part was good. So the issue is not being physically connected, it's being mentally connected. So if you understand this, it doesn't matter where we are in the world, because the issue is not physical, it's mental.
As a matter of fact, to make it practical for you, Willem, the question is great. So in your case, for your organization, does everybody has the same idea of what the customer wants? Does everybody have the same idea of the type of brand you are, the position in the market you have, the type of customers you serve? Does everybody has the same idea of that? And if that idea is identical, then you are mentally together and you can work together, even if there's a digital distance. But quite often we do these surveys in organizations. We go, when I'm in an organization, I always talk about the customer and the competitors. I always bring them to the table. So first the customers, to learn if they understand the customers. And quite often it's limited. Go to an HR department or an engineering department or a production department, ask who are our customers. Well, quite often they cannot even name a customer by name, let alone they know what they want or what the purpose of the product is or what the customer is doing with that. And that's what Bill is emphasizing on. Do we really understand deeply what the functionality is of our services or products to the customer? And there is the distance.
Well, the other thing I'll add to what I mentioned earlier is that when one of the first teams at Rocketdyne demonstrated 100% snap fit hardware, other teams tried to replicate that naturally. And I got invited to a meeting of one of those teams, and the guy leading the team was very frustrated. He called out a whole dimension with an ideal value, and all the holes are made to the low side. And I went in and I said, so what's the issue? He says, yeah, I'm aware of the target thinking. I put in the drawing a target value. The plate went out to a supplier. Look what they did. They made all the holes to the small side. I said, here's the issue. And he says, I told them where to focus, the ideal value. I said, you also told them with the red lines that it doesn't matter. And this is a situation where these people had no understanding of what an ideal was. Yet other engineers I worked with were literally carrying a piece of wood around with them, going to a supplier with a piece of wood with a line on it and saying that line there, that's like the line. And so what we did at Rocketdyne, the majority of people at Rocketdyne went through a 9-hour exposure to this. And quite often, once a year, it'd be updated because the seminar changed. And that created within the organization a deep understanding of a lot of basics. That people that did it that way transferred the results. The ones who thought all you got to do is call out an ideal value got burned because the people on the receiving end don't know an ideal value. What they know is min and max.
And that's how it works sometimes, yes. All right, thank you very much. A final question, otherwise we're going to close. Any other question, please? No? All right. Then I thank you very much for your time. We loved it. Thank you on behalf of Bill as well and the whole Patagonia team. Wonderful. And if you like, please feel free to join on the 20th of March. Another management principle for preparation of your own organization, or if you like, for the 7th of May, when we do the event. Thank you very much. Bye-bye.
Bye bye.
Thanks,
Thank you. Bye bye. Bye bye.